Welcome, everybody. Welcome to SCaLE. This is the Personal AI workshop, and it's 2 hours, maybe an hour and 45 minutes of presentations of deep technical stacks that are all in the personal AI space. I'm going to introduce to you the CTO of Mimik, Michel Burger. Mimik's got a fantastic platform. You really need to get to know it. It is a platform that allows you to choreograph hybrid edge complexity. Imagine bringing AI down from the clouds and running it at the edge. Well, now you can do that with a framework from Mimik. And Mimik has been the sponsor of Kwaai. Let me tell you a little bit about Kwaai. Kwaai is a non-profit AI lab. You'll hear more about it later on in Hall F. This is an opportunity for our sponsors, a number of vendors, to describe to you their tech stack. So with no further ado, let's introduce Michel Burger. Thank you.
So good morning. Thanks for being here, and be ready, because we're going to show something quite amazing. So I'm Michel Burger. I'm the CTO of a company called Mimik. And today we're not just talking about AI, but we're talking about liberating AI, meaning that now we need to go to the full operationalization of agentic solution to break from the rigid, costly cloud infrastructure. So at Mimik, we believe that the intelligence should not be stuck in the cloud, but should be in directly on the device and directly where the data is generated. So what the problem? So traditional AI, they rely a lot on the cloud. Like when you look at OpenAI and Gemini and others, and they're really obsessed with it. So which means that everything is going to cloud, which induces latency, privacy issue potentially, and then a scalability nightmare. So which means that AI should not have to wait. So they should do things directly. So the solution is really operationalizing agentic solution or agentic AI at the edge. And it's where we flip the model on its head. So it's not anymore the device being passive and sending data to the cloud. It's now the device are becoming by themselves autonomous and intelligent agent. So this agent will think, collaborate, and act locally in order to reduce the dependency of the cloud, enhancing the speed, the security, and the efficiency. So at Mimik, we've done that. So that's what we're going to show you now and at length. So, but first, let's talk about agentic solutions. So agentic solution are well known, but it's a lot of things. I mean, to look like a lot of things, like from execution to deployment, from a single agent to an ecosystem of agents, from one vendor to a sprawling web of vendors. And all of this is challenging because it's not all about making AI to work, it's about making AI to work together. And that's one of the things. And it's funny because it sounds familiar, and it is. I don't know if you remember the Web 2.0 era. When the Web 2.0 era, everybody was doing mashups, and everybody was bringing web service together in order to create solution, and everybody was amazed, like a Google Map with another feature, and you were bringing the two things together. It was creative, it was chaotic, and literally it was a mess. Why? Because when something was not working, everything was collapsing and so forth. So AI, for me, and especially agentic solution, are the same level. So which means that they bring things together, they show a nice prototype, then they show a nice UI, but then when you look deeper, you realize that it's still disparate and it's still disconnected. So and we need to change. We need to change the game from we need to change from disconnected, disparate and half-baked experiment to really innovative solution. And what the missing piece, again, the operationalization. Like it's about a lot of things about management. So when the service goes down, how do you alert the other things that the service is down? Or how do you monitor everything? And I will talk about it, but I don't know if you're familiar with a framework called FCAPS, fault, configuration, accounting, performance, and security. So every node of a system should follow that. Like in a network, I come from a network background, and every node had something to say about FCAPS. Like the light of a router is F, because if it goes red, mean it's not working, and so forth. But what about microservice? What about AI agent? They should follow the same principle, where if an agent is not working, you should be able to know about it. And that's one piece. And all of this is part of the operationalization of AI. And then you have the stage, because in a sense, edge AI is not just a buzzword. So it's really a way to shift from cloud to edge type environments. And you have to break it up in different stages. So stage one, it's about local execution. It's where the AI stands on its own, meaning that you should be able to execute a model directly on a phone. Because if you start to have to depend on the cloud to do this, and the cloud is not available, again, nothing is working. So for me, mean that like facial recognition, voice assistance, industrial monitoring, all of this should not depend on the cloud, and then you remove a lot of things like cost, latency, and things like that. It's fairly there, meaning that you see more and more solution with cameras and things like this, where the camera execute the model directly. But again, it need to go further. And where it need to go further is contextualization. So now it's where the AI understand the bigger picture, meaning that in this case, the AI knows the context in which it is, like the where, when, and what, and then you behave and adapt to that. So this is where like a wearable, for example, becomes a health device in one case, but shift to a navigation device when you're in the car, or a combination of both. It's where like it's also where things are self-improving, because based on the context, I can start to say, okay, I need to change even my model. So maybe I should download another model to start to behave more appropriately. So that's the next step. And that's where AI don't just work at this point. They anticipate, they react, and they evolve. The next stage after that is AI to AI communication. It's that model talk to each other. So that's where an AI working alone is fine, but an AI working in collaboration with other AI in order to find a solution, it's even better. So when you look at a group of experts, an expert is great, but having a group of experts looking at the problem from a different aspect is even better. And that's something we ought to look at. So that's where models interact between each other. That's where the collective intelligence is in action. So now you see things happening collectively and not just one. And the last piece is cross-domain, meaning that now a health AI should be able to talk to a home AI, or a health AI talk to a car AI to help the driver when the driver is falling asleep or something like that. So that's where you start to see that cross-domain lead to the fact that very soon there won't be any domain. Everything will be just one big system. So this is where AI don't work just in silos. They're forming an ecosystem. The last is adapted choreography. It's where now the workflows themselves are very dynamic and very agile, which means that it's not anymore about being orchestrated by one thing. It's more the fact that each component start to behave based on the event they receive or based on the context in which they are. So the combination of both lead to the fact that now everything is much more reactive. So you go from automation to autonomy. Like you define system where the flow adapt itself to the environment and to the AI which are part of this environment. So the bottom line is we need to operationalize all of these 4 stages. And that's where it's not just a basic execution, it's really about fully agentic AI ecosystem. And that's now what I will show as a first architecture diagram. So what do you need to do when you develop such system? So your application need an AI environment, so an AI execution environment, because you need to be able to execute models. So for example, if you're on a Mac, you can download Olama or something like this. So in other case, you can have a CPP Llama library in order to really execute the model directly, which is convenient because then you don't have to pay the API of OpenAI or things like that. Then you generally need a model management because you will want to fetch different models based on the context, based on a different thing. You may want to fetch, and either if the model is here directly or it's in the cloud and coming on the device. Anyway, so you need to fetch model. Then you need an AI chain, like a LangChain or LangGraph or some kind of framework like this, because you want to coordinate. In the agent terminology, it's more like a coordination than orchestration because everything is much looser in a sense that the agent are more autonomous. So that's where LangChain, for example, library will help. Then you will have the LangChain calling the execution environment to get a response. So now you get a prompt in the LangChain, and you now reflect the prompt on the AI. You may want the LangChain may be sophisticated enough to call cloud AI as a subsequent refinement, either at the prompt level or at the response of the prompt. And then comes another device. So of course, if you see the device and if you know about the device, you will have to do this. However, that's not working this way. Why? Because how do you know about this new environment? And that's where generally you need like a cloud discovery where every node declares themselves, which means that now your app will invoke this cloud discovery to say, okay, so what is in my context or what is there, what I can reach, which means that at that point, because you do this, now you can reach it. However, for doing this, you also need a security model because of course the connection needs to be secure, and you need then like another device come, same story. You have model, now you would like to do this, but it doesn't work. You report this, but there you will also need an API gateway because now you need to expose an API. So it's not because you have a process running on the device that you can access a process, which means that an API gateway will be needed. Again, a security framework will be needed. And now you can reach this new node and can fetch, for example, the response of the camera or the feed of the camera or the analysis the local AI on the camera has done. But basically, you can fetch that. And then, of course, you will need to observe everything because debugging a system like this is actually not trivial. So, of course, you need some form of observability framework in order to do that. And then what is even more interesting is because you've done all of this, sometimes you will like other applications to benefit of what is already installed. However, not possible because you have you're missing an API gateway. So sorry, I'm fine now. Yeah. In Mimik, we've provided such thing, which is the different building blocks in order to actually build an operationalized agentic solution. So one of them is called MIMOE, and MIMOE is really the backbone of the agentic AI. So think about MIMOE being an operating environment which run on any device, on most of the operating system, and provide you a series of things like microservice runtime. So which means that now you can run a microservice or an agent because you have the ability to do it. You have an AI runtime, so you can execute model directly on the device. You have a node discovery, meaning that we spend a lot of time figuring how a node can discover other node in the same subnetwork or in the same proximity or in the same belonging to the same account. You have to have, then you form something called ad hoc service mesh. So in the back end, people talk about service mesh all the time, which is kind of like the combination of all the microservice which forms the system. So why not be able to do the same thing at the edge? And with Mimik, because of the discovery, and because when you discover the service that run on top of this operating environment, you can actually create this service mesh. Then you have an observability framework, a zero-touch configuration, and finally, because you work at the edge, it's zero trust security. Why? Because at the edge, every node can be a threat. So you don't have the luxury of having a firewall which surround all your components, because basically any component is a foreign component and a trust framework has to be established. Then, because of that, we form now the backbone, but then we need also some microservice to facilitate the creation of agentic solution. And that's where we have created a series of helper microservice. One is called M-model store, which basically store a model and expose an API, which means that now you can fetch it in order to retrieve the model, and either in the same node or on separate node, doesn't matter. MILM, that's basically exposing your AI runtime as an API, kind of like an open AI, but local, where now you can invoke the agent and get a response. NKB, that's a vector, a mini vector database for RAG, retrieval augmented generation, which allow you to store embeddings and then retrieve embeddings from that database. MAI chain is a kind of equivalent to LangChain, but as a microservice. It's a way to coordinate a microservice together and basically build the whole solution. And finally, we have something called MInsight, which is a way to observe what happened, either because you know which microservice are in the context or the event which are flown between the different microservices. So with these two things, the runtime the operating environment and the series of microservices, we basically have provided a way to operationalize agentic solution. It's not just a theoretical framework. It's very concrete, because at Mimik we're generally very pragmatic, maybe a little too much, but that's where we are. So now, how does it look? The same solution I showed before. How does it look with Mimik? So you have this operating environment, which now run MILM in order to invoke the AI runtime, which is fetched from the other model, which is fetched from a model store. So you have another one. In this case, MLM act more like a proxy to expose, to make an AI which is not discoverable. So for example, in NIM, which is NVIDIA Inference Microservice, have exposed API, but they didn't make it observable. So we help them for doing this by creating a proxy, which means that when you create an AI chain as a microservice, you just have to invoke memory. Memory will give you the context of which microservice are around, which means that you can immediately do that. You can call the local MLM, you can call the remote MLM or the MLM which is in the same context but on another node. You can actually call a knowledge base if you have one, and then you can potentially call other microservice to refine either the prompt or to refine the answer based on the prompt. Which means that if you have another device running memory, same thing, all the blue component will be immediately discoverable, which means that the AI chain will adapt because the context is constantly maintained, which means that either the AI chain or the memory to receive the context, or the context, the memory inform the microservice, but basically the microservice will know about the change of the context. And in this case, we'll see a new microservice, which is about a result of a video feed. And then you now have the video feed, and the solution will be invoking the different things. So it means that your application, instead of having implemented all of these things as part of the application, will just invoke microservices in order to do it, which means that it makes the application much more simple, and it makes the agentic solution much more solid. So which means that you get the benefit of both by doing such thing. And you can see now all the stage represented in this case. Local execution, contextualization, because of the fact that memory keeps the context. AI to AI communication, like an AI on the camera will talk to an AI on the device. And by the way, this device could be a phone. Like we are going to GTX, like the NVIDIA conference, and we will show chain and a bunch of solutions where the phone are involved and do actually a lot of things. And finally, you have the whole thing is an AI adapted choreography. And of course, if you now add another app in order to do something different, either the app calls the same AI chain to basically get the same result, but render it differently, or do something differently at the app level, or potentially can call directly the different elements which are already there, like the knowledge base, the agent, even the store, in order to store something else, or create a new AI chain, which will create a complete different solution. So that's kind of like the capability of memory. By exposing local API, you basically recreate this notion of thin client, but now instead of depending on the cloud for what the thin client will invoke, the thin client will potentially first call local API before calling remote API. And that's where you have your own agentic system, because of the fact that on top of that, you add the observability using MInsight, which means that you have all capability to debug, to monitor the performance and things of this nature. So here's the case that there is something which is about this operationalization and this management aspect. And I was at Microsoft and I wrote a Think Quick paper, which was about well-enabled services, because we realized that these mashups they were great. However, again, from a management aspect, they were horrible. And this led actually to the creation of a product at Microsoft, And I had my Bill Gates review, so if we have beers, I can tell you what the story is. But anyway, and this paper was talking about the fact that a service, yes, need to expose functional API, but then you have a whole bunch of non-functional requirements which should be exposed as API. And the framework was based on this FCAPS concept. So, if you're a system engineer or if you are a network engineer, you know what I'm talking about, but an application guy will not know because the application, they don't generally deal with such thing. And FCAPS, fault, configuration, accounting, performance, and security. And all of this makes a system manageable. And so it's time to apply the same concept to AI agent. And that's what you see is that an AI agent have to be offline first, because it's all about running autonomously and independently. Then it's about being discoverable, because there is no point of creating an agent if it's not discoverable like this. There is no ghost hiding in the dark or things like that. You need to expose yourself, and you need to declare yourself in some ways. You need to be context aware, again, because either at the edge or even in the cloud, you need to be able to understand where you are, which means that now you understand what's running around you. So which means that it's not just about running, it's all about understanding the environment. Then you have observability, which is F, A, and P of FCAPS, because it's about like a fault aware, accountable, and performance optimized. So that's basically what observability will give you. Then you have zero trust enable, that's the S of FCAPS, because it's not, it's really about securing everything. And finally, you have zero touch configured, which is the C of FCAPS. So basically, that's kind of like the new FCAPS, but for AI agent, in order to make a system operational. And that's what Mimik has spent a lot of effort. So we're not providing model, we're not providing like this fancy client which everybody look at. We provide the tools in order to make all of this solution much more solid, much more variable. Because in a sense, like I have this quote, which is an AI solution which not operationalized, is just a fancy set of API with no commitment. And that's basically why we created Mimik. So go to mimik.com. We have a lot of material in order to we'll go through all of them. So you have a lot of material from GitHub to the Memory website, where we have training. We're using Instruct for doing the training. We're using, of course, GitHub to show example code and things of this nature. Thank you.
We've got time for a few questions. Speak up loudly so that we can pick up the audio. We don't have a roving mic. And great, we've got a question here, and then John next.
In your architecture, you put that large language model on the cloud. Is that because the large language model, if I had to put it on my laptop, it's around 5 gigabytes?
Well, but remember that you on a device you constrain with the memory footprint.
Okay.
So, for example, on an iOS, you cannot run Llama 3.2, so that's not make sense. However, you can run Gemini 2 billion parameters. So, which means that you can run some LLM, but they are limited in size. But the large language model, like the new, no, they are like 43 gig or things like this. You cannot run on the device.
And you are only providing the software.
Yeah. Okay. Yeah. Okay. There is a guy behind you. Sorry.
For context, and don't take too much time on it, but could you explain the real world use case of your maritime solution so that people can get the concept of your tech in action?
Oh, yes. So we have a solution called hybrid tracks, which is literally about check-in, check-out, scanning, scan out on a ship. And all the devices are actually Android devices. And they all talk to each other in order to create a system where you have people with scanners, they scan, and people with more tablet, which they look at the solution as dashboard. And the novelty of this is there is no gateway. There is no central computer, even on the ship, because they will not allow us to install it. And all of this is based on agents collaborating between each other and on Android device. And it's about really tracking people. It's about checking people when they go in the boat and then when they exit. So it's a lot about how to manage a crew of people.
For the sake of, we don't have a mic for questions, so repeat the question into the mic.
Okay.
Okay. My question is, when you have your own, your own instance of this particular thing, will the AI be able to record all of your activities so that it then can personalize and like when it writes for you, it'll write in your voice?
Okay, so yes, but that's a combination of two microservices. One is MLM, which basically, oh, sorry. The question is, will an AI be able to remember what you just did? And yes, we can, but that's a combination of two microservices. One is called the MLM, which is basically the AI itself. And then you have the MKB, which is a model store, where basically the embeddings which are generated by the AI will be actually stored in the vector database, which means that when the AI chain makes a query, you can enhance the query with what was stored in the embedding, which was stored in the MKB as embedding.
With the it's a mini LMM, right?
Yeah, many LLM will be able to behave as a coordinated environment.
Okay.
Great. Okay. So thank you very much, Michel Burger. That was fantastic. Okay, so if you want to do anything at the hybrid edge, take a look at the Mimik stack.